All right, now let's have you try one. So similar problem here. We want to use the sum of the first 10 terms to estimate this series of 1 over n squared. Um, See if you can improve that by finding the range of values that the infinite sum can be between with n equals 10. And then for part C, they want to know what would n need to be so that the error is within 0.001. So try these out and then watch the video. Okay, so for part A, hopefully you had a chance to try that. They want you to find the sum of the first 10 terms here. So just use your calculator, type this statement in using that calculator, which should look something like this, and you get a value of about 1.5497. So I mean, remember to find that in your calculator, math, and then on the bottom you want to use that summation. All right, next part of that, they want to know how good an estimate is that. So we want to use here that our R value, our error, should be less than or equal to n to infinity of that series. I'm just going to solve it with n in there. So 1 over x squared is the same as x to the negative 2. There's an antiderivative. I'm going to introduce a limit as we go to infinity in here, since we have infinity as one of our limits. And that'll be the list statement. And then we know as this one goes to infinity, that's going to go to 0. Double slash here, so we just get that. So if we're using 10 then, because that's what we told us in the problem, our error should be less than 1/10, or 1/10 is the same as 0.1. So we know our answer is within 0.1 of the actual answer. So our estimate is within 0.1. All right, so part B, improve this estimate. So find the infinite sum is what they're asking with this number 3 here. That was our thing before. So they want us to estimate what's our infinite sum of n equals 10. So to do that, our infinite sum here should be between our estimate of s of 10 plus the integral from 10 to infinity. And then on this side, we want one more than that, so 11 to. Again, we know our of this integral is going to simplify to 1 over n. So I kind of use that here. If this is 1 over n, this is turn into 1 over 11. 1 over 10. So if we add that to our calculator's estimate of s to the 10, we're going to get 1.649 on this side. If we do the same thing but add 1 over 11, we get that. So our infinite sum is somewhere in between these two. We're going to get it down. All right, last part. They want you to estimate what n would you need to use so that the error came out to be less than 0.005. So if our error has to be less than 0.001, use our error again. It's going to be less than this. We know from before that simplifies to just 1 over n. So 1 over n needs to be less than our error. So then times both sides by n. Now you got this statement. Let's divide both sides by 0.001. That means we got 1,000, and so our n value needs to be greater than or equal to 1,000. So we would have to use 1,000 terms to get our error